How's it going, everyone? Welcome again to today's video as a way to look at now this NeetCode with LeetCode. So this is now a roadmap that this software developer that has previously worked at Amazon and then Google actually create as a way to now understand is the common patterns when it comes to solve real life problems using this particular tool, data structure and algorithm. All right, so how now you can use, for example, this an array and hashing to solve these common problems. So for example, hey, is this collection of elements contain duplicate? Is this a valid string or working with strings? Hey, how can now you actually check if or how you can work is with indexes from array as well as called hashes. And also when it comes to identify elements in a collection of values, how useful is use a map as a way to identify them, right? And last but not least, and I think that was a very interesting topic, which is now giving this collection of elements, I want you to identify is what is the most frequent giving a specific so I want to know how, if you have if you have a shoe inventories, you want to know which of them are which is the top 3 most frequent elements. So the idea of this is to see how useful it is when it comes to actually solve real life problems. So instead of you having to manually do that, you can use these data structures as well as the built-in method that come with, and as an array, and with array and hashes as a way to solve this daily business operations. So that's quite interesting and powerful. So with contains duplicate, you can use now is the set built-in method as a way to now get a particular array from that. All right. So for example, like this. So this is the solution of this particular problem. So we use this as set. As long as we get is this collection of elements as a number, okay, we can now identify by creating a set, hey, which one of them are already in our collections. Another more interesting and fastest way is to pass this array as an iterator, because at the end of the day, set the MDN this data structure. A set is in the constructor. A set is set objects. Okay, well, it allows you to accept that, but it allows you to pass these iterables. All right, which is an iterable object. It is optional, but you can pass as an iterator, and then it's going to have now this specific data set, which returns a set object. All right. So, and then if you want to work with this data structure, and the reason of we using set is because now we can work with several. So now that you have this set, which is unique values, all right, then you can now ask questions to this set. So for example, hey, give me the difference. All right, again, this is something that is fairly new in this. Okay, so hey, give me is now based on this two set, give me is the difference of this, which means is that what are the elements that are not give me the elements that are not give me all the elements that are not, so give me the difference of this elements here. So give me the difference of elements that are not present here. So for example, you say 1, no, 1 is present. 3 is not present. Okay, 3. 5, no, 5 is not present. I'm going to give you that. 7 is not present. I'm going to give you that. 9 is present. No. So not only this, okay, which is something that you most of the time want to do that, even though it wouldn't be part of this. The other is intersections, but all of this is just useful way as a way to now work with this data structure, okay, and as to solve common specific problems. The other common specific problem is, for example, the two sum. And here when we say, all right, now how can we work with a collection of values as a way to now use the, as a way to identify is which one of two elements, and there is only one solution, which are the two elements that in these collections of values match the target when they add up. When you add up, when they add up, match the target, right? So by working now is this with the collection, as well as storing in an index. This is the entire reason we read or write as a way to write in an index, pretty much like write, completely write, as a way to write in your hash. Hey, I want to now put the index in my as a key. All right, I want to put is the index as a value, and as a key I want to now is store is the difference that actually match. So when I'll iterate through all of these elements, okay, I'm going to put now as a key is the difference. All right, and once I iterate through that collection, then when I come to actually identify which one of them actually match that target, as I move on through this and keep track the index and the key, now I will be able, when I find that, then I'm going to return you that. So this is, in the worst case scenario, ON. So the idea of doing this is like, see how you can work with arithmetic, this counting, okay? Arithmetic counting, and data structure and algorithm, data structure and a series of steps, okay, as a way to achieve something. In this case, that is specific problem. The other is that now giving a collection of values, how you can now work with strings, and especially with JavaScript, with group anagram. This was a quite interesting exercise as a way to now, okay, but I think no. Oh, valid anagram. First, working with valid anagram as a way to now is see how you're going to detect if there is a valid anagram, giving a string, okay? If this is a valid anagram, as a way to work now with strings and with the UTF unit code to compare those strings and then give you that. The whole point of this is to see how now you can work with strings, which is the layout, the laydown, the basic building block of connecting all of this, of to work with. So string. And now here with group anagram is a way to giving a collection of elements. I want now is to write in a table, in a hash, all of this group or grouping elements here. So this is now the pattern that is unlocked anytime you actually need to find that kind of thing. Hey, I need you to is I need you to is group all of these elements together and then send that response as a JSON. That's one of the reasons why especially Node.js developers are in demand, and if they are good at what they're doing, and if they know how to improve or use a common built-in techniques or techniques to get or to process this large collection of value in the fastest way possible, I think that I recognize the value here. I recognize the value completely here, because time is the most important asset that a person has, that we as humans have. So, this algorithm was solved in the group anagram, was solved in ON in terms of space and time. All right, and another is the top K frequent elements. This was also a very interesting theme, because again, this is what most of the time we're gonna do in our daily life. Okay, so you want to know is okay, so what are the most common things that you buy in? So what are the common things that you buy? What are the common things that you eat, for example? You know, in a week, in a month, 3 months. Okay, as a way to actually understand and to see, hey, how can I now, for example, is save more money, okay, or to allocate that save money to other things that I would like to. The K most frequent elements. Another example is in mechanics. Okay, so how many of these nails do we have here? Doors, transaction. This is also useful, for example, in security. Is that how many people are getting here and how frequent these persons are getting here in these particular hours as a way to secure your assets. So this silly exercise, easy exercise, is now allow you to now is apply to all of the different areas, which is something that most of the time, especially as you're learning this kind of thing, you recognize. It's like, oh, I get it. It's like, oh, I get it. It's like, oh, I know when I need to apply this kind of thing. So the top K frequent elements, which is, I just want to briefly recap this, right? All right. No, this is not the big front end. In fact, is here NeetCode. All right. Yep, that's right. Arrays and hashing, algorithm and courses. Nope. Here the algorithm here. The solution that he implemented was based.
Hey everyone, welcome. So this problem index of the array in this algorithm actually store the bucket sort values is going to actually another tricky way that you can do it that will lead us to a linear time solution. So if we're pretty clever, is for this position 1, we're going to say, okay, guys, so in the position 2 index, how many times? So you know when we're frame, what if we had each one position? So that's still technically linear time. Now we are creating this array to help us, and we're also going to be needing a hash map to count the occurrences of each value in the input array. So the memory complexity is also going to be big O of n. With that being said, let's jump in.
So this was a very interesting exercise, because now here, what happened? So now that you have this collection, let me actually here it is. So now that you have this collection of values here, you want to know what is the most frequent elements. You want to know what is the most frequent elements here. So in one particular case, what we did is to say, give me this array, okay, where I'm going to now count all of the instance, okay. So in my hash, I'm going to store now, because I want to know is the most frequent elements here. In my hash, I'm going to store now is as the value. Exactly. In my hash, I'm gonna now Yeah, in this hash, I'm going to store is now all of this. We're going to write is the number of occurrence. Okay, so given the number, and I'm going to count that, I'm going to iterate through all of these elements, which make is the time complexity of O(n). All right. Once I get that element, I get that map with all of the counted numbers. Okay, they count as the key, so the number of the key, and they count as a key. Yeah, they count as a key, and the they count as a key, and the number of occurrence as the value. Then I want now is to, I'm going to iterate through this array that I'm receiving. Why is that? Because no matter how long is this, if this array is all of the elements in these arrays are 1, okay, we have now to count each one of those elements. All right, so we're going to reserve space in memory for those elements, especially because the reason of this is we're going to use something called is the bucket sort. Okay, is the bucket sort. Is the bucket source. So these buckets are formed by uniformly distribute the elements. Once the elements are divided into buckets, they can be sorted using any order sorting algorithm. Finally, the sorted elements are gathered. But again, this is go perhaps a little bit beyond that, because so far we haven't involved with this bucket sort right now. Okay. But the idea of this is that since we receive all of these elements here since we receive all of these elements here as this since we receive these collections of numbers here, even though that each one of them has a 1, all right, we still need to have to count each one of them. And because we want is to create is an array that will contain some sort of bucket, part of the bucket sort, okay, which means that this new collection or this new array, which will be is the same length as we're receiving, okay, in this new array we want to store is now in our index, which represents the number of in our index, which represents the number of occurrence. How many numbers or how many elements do we have that have this occurrence, right? Whether it's 1 or 2 or 3 or 4 or 5 or 6. So now the space complexity is also O(n). And that's exactly what we do here, right? So we say, hey, now let me iterate through this array, okay, where I'm going to now populate is in this new bucket collections, this array, as the index, as the number of occurrence, and in there I'm going to use a set as a way to now add only unique values here, okay, based on the values that I get from my map, okay. So based on the values that I get from my map, hey, is this value exists, okay, now is this value exists, which contains the number of occurrence. I want to now put that I want to put that in that index, which contain is which contain is only the numbers there. Okay. That it contain is now is this. That contain now is this array of these collections of unique values. And then what I'm gonna do is to, now that I have this new array, this collection, okay, where each one of those positions indicate or represents is the number of occurrence, then now I want to sort them, okay, which is something that you can do that. I want to sort them in an ascending order. Since this is numbers, it's going to do that behind the scenes in JavaScript. Then I want to reverse that as a way to now get the most frequent elements. Okay, I want to now is apply a transformation to all of these numbers, which if you don't do this kind of thing, for example, since each one of those elements contain is now an array of that, okay, because it is a set, and then you want to transform this into an array for that, okay. This is the way of how you transform them into an array. I want you to now flat them. It's like, hey, remove that element for that, or remove that array structure, put it into a one level array structure. Wait, what? $57. What? Okay. $57. Word frequency and that kind of thing. So the idea of doing that is like, once you do this, okay, now I want you to now slide this element from the most frequent onto that position. And that's quite interesting. So because here you are working is with this huge collection. Imagine that you're working now with 1,000 millions of records, okay? Actually, JavaScript is not the best way to handle that. There are more faster language that allow you to work with that, which is kind of great, kind of cool. But yeah. So what we are going to do now is, so now that we solve this, all right, and what we're going to do now is the encode and decode strings. All right, let's going to dedicate now 20 minutes to read about this. Please provide me this. Yeah, encode and decode. Okay. What, for real? I need to subscribe to get that? For, god damn it. I need to subscribe to get that? Alright. Anyway. String encode and decode. Design an algorithm encode a list strings to a single string. The encode string is then decoded back to the original list of a string. Okay, design an algorithm to encode a list of a string to a single string. Now to a single. The encode string is then decoded back to the original list of string. Please implement encode and decode. No, but I want to first design an algorithm to encode a list of a string, to encode a list of a string, exactly, to encode a list of a string, to encode a list of a string, to encode, okay, to encode a list of a string to a single string. The encode string is then decode. Yeah, what the F? Design an algorithm to encode a list of a string to a single string. Okay, encode a list of a string to a single string, and encode the string is then encode. What do you mean by encode? Yeah, what do you mean by encode, bro? Okay, to transform from one. Okay, okay, encode transformation. So design an algorithm to encode a list of a string to a single string, and decode string. The encoded string is then decoded back to the original string. Okay. The string, the constraint here, please implement the encode and decode. The string here, it tells us here that is C, that can start from 0 until 100. This is now the string length, okay, which is the decode, and the array of or the list of string, which can be up to 200 elements you can have. And the string I contains only UTF character. So one easy way to do that in JavaScript is by using all of these built-in methods. So for example, in strings, okay, you can say something like this. I want you to now return is the string. Since this is now an list of string, I already received that as an array of a string, and I want you to now is join them. Okay, join them by that. Pretty much that. And you want is to now return is that. So if you wanna know what the join is doing, what the join function is doing in arrays, it joins. Okay, it joins all of this. By concatenate all elements in a separate by comma or specified separated string. In the array has only items. If the array has only one item, the item that will return without using the separator. So for example here is that the return value, a string with all arrays joined if the array.length is greater than 0, which is what happens here. The string conversions of all array elements are joined into string. If the element is undefined or null, it is converted to an empty string instead of a null or undefined. The join method accessed internally by array.prototype.string with no arguments, overriding join for the array instance will override to a string for that. Array.prototype join recursively, recursively convert each element, including other arrays, to string, because the string returned by the array.prototype to string, which is the same of calling join, does not have delimiter. A nested array look like they are flattened. You can only control the separator of the first level, while deepening levels Well, deeper levels always use the default comma. Okay, so by default, exactly, you can only concatenate you can only control the separator of the first level. Interesting. Of the first level. When an array is cyclic, it contains an element that is itself. Browser avoid infinite recursion by ignoring the cyclic reference. When you use a sparse array, the join methods iterate empty slot as if they have values undefined. The join method is, when they say sparse, is arrays with undefined values. You know, array with undefined values. Array can contain empty slot or space, sparse arrays. What does it mean, sparse? Sparse meaning Jesus. A few or scattered elements. A small in numbers or amount, often spread over a large area. Sparse or scatter. Okay. Okay. They call this sparse or scatter. Okay. Sparse arrays. Sparse arrays. Okay. They can contain empty slots. So the join method is generics. It only expects this value to have the length property and integer key properties. So joining an array 4 different ways. Joining using join to sparse array. So for example here, and they're gonna take that in consideration. They're gonna add that to an empty array. Calling join or non-array objects, like so. Calling join or non-array object, but as long as that contain is that an array like. Okay. Ignore by join since the length is 3. Even though you can now join elements, that's why join values here in an array as well, as long as they have implement length from that. That's quite interesting. But in our case, because now this join is going to concatenate all of these elements, and also I want is to now is remove, okay, input and output, okay, and then okay, and then on the decode, since you receive is this string for that, which is this long string, all right, we will now transform that, which is split this, which is now an array method split and a string method split here, which now transform that. It takes now a string and a split, giving a particularly character or a particularly separator. So in our case, we're gonna do is this, and that'll be all. In JavaScript, you have now this nice little convenient feature for that. Say, hey, oh, because I must return that. My bad. Okay, it say now your input. Oh, but look at this. All right. And output. Exactly. So perhaps we want to use this as a separator, like so. Right? So what happened is that by default, the join method, it will transform it into a comma separate values. You know? Exactly. A string separator on each pair of adjacent elements of the array. If omitted, the array elements are separated with a comma. Exactly. However, in my case, the separator that I want to now split this is using this. This is something trivial in JavaScript, okay? But when it comes to now work with this kind of data structure from lower level language, for example, like C++ or C sharp, okay, as a way to now do that kind of thing, you need to now work with this list, okay, and work is with this data structure. They don't provide you these nice little convenient features like this. So, for example, if we already have our list here, we will need to, if you implement that, for example, in language that doesn't have any of these methods, you will have your collections that each from the encode that will contain all of these streams, okay? And then once you iterate through that, then you want to store now a value. You want to hold a value where you're going to now is append all of these elements into that variable, okay? Let's say a string, okay? You want to append all of these elements into this value as you iterate through all of these elements in the array. And then you're going to return that variable that contains all of these elements concatenated and do that, right? So this is actually quite simple. So far so good. And the split here, in the split, you're gonna now find is and on the split, because now you receive is this long string, okay? The idea here is using is a separator in both cases, okay? You need to use a separator in both cases as a way to now identify is this, okay? When you're going to create this concatenation string, okay, where you're gonna hold that using the separator. And the other is when it comes to now decode that. Okay. Input your output. All right. Okay. So we don't want, okay. So what we can do here is that I want you to now, after you split that, okay, filter, since this is now a collection, I want you to filter for those elements and only get me is those elements that actually are different from empty. All right. Input your output, expected output. Interesting. Okay. Okay. Exactly. It's to now deal with these edge cases here. All right. All right. So now we're going to actually deal is with these edge cases. If the string dot length is equal to 0, then I want you to return is now an empty array. Otherwise, I want you to now do this. However, if the string dot length is equal to 0, again, I want you to now is in this case I want you to now return is this empty elements what we need to do now is return this array for that. So now when you run this, okay, input is this. Okay. Exactly. It's now to actually check that. Exactly. So if the string and the string dot and the string so now you want to check if that so if the string or you can say if the string exists, it's going to make it, here we're just evaluating these edge cases. Okay, here we encode it, right? We encode it with this separate value. Because here in this time we're actually receiving is as an empty array, or whether it's an empty or a string empty, okay? We can say is, hey, it's now checking is, you can say string is equal to this. Please return this. If the string is equal to this, please return is that. This is a way to cover these edge cases. Okay.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve the problem encode and decode strings. So you can tell the interface is a little bit different this time, and that's because we are going to be solving this problem on LintCode, because this is a premium LeetCode problem.
One possible encode method is LintCode love.
And we can solve it for free on the website LintCode. And also, this is a problem from the Blind 75 list, a list of 75 common LeetCode questions that we've been tracking on this spreadsheet. The link to this will be in the description if you want to take a look. And we're pretty much done with the main problems. I'm going to be solving another one today, a premium one, encode and decode strings. This is a pretty decent problem to understand, so let's get into it. So it's a bit of a design algorithm because we're going to have two different functions that we want to implement. So we're given a list of strings, and we want to write two functions. We want to encode this list of strings into a single string. And you can kind of see that down here. We were given an input list of strings, LintCode love you, and we want it to be a single string, such as this one in the bottom right, and then
one possible encode method is this. But it's because it's not quite clear also. You know, it's because it's not quite clear even the answer here. You know, it's not quite clear. Actually, we solve most of the common edge cases. But when it comes, most of the cases, but when it comes to actually dealing with now.
hey everyone.
No, come on.
Lowercase a to z. So the up to us on how we want to design. The decode is just going to be the opposite of encode. We're going to be given a single string, and we want to be able to convert this string back into that original list of strings that we were given. And it's up to us on how we want to design this algorithm. But the tricky part is going to be that the basic assumption is that in our input, we could have any possible character in the inputs, not just limited to lowercase a to z. So the difficult thing is going to be, how do we create some kind of delimiter between each word? How do we know when one word ends and another word begins? That's kind of what we're going to be focused.
Okay, this is exactly in lower level implementations, which is something that I explained earlier. Okay, but because we are using is now these convenient functions like join and split and slice or split, sorry, from JavaScript. Now they say, hey, what will happen when I pass you an empty array? Because what happened is that we rely heavily is on the inner mechanism of the split. You know what I mean? So because of that, and because we are heavily relying on that particular separator here, because that's the entire reason of this, we are heavily relying on these heavily separators. Okay. A non-negative integer specifying a limit of number of substring to be included in the array. If provided, split the string of each occurring of the specified separator, but stop when the limit has passed. If limit is 0, return 0. I think this is an option that you're passing, or what, a function here? String and separator are both empty string. Using a custom splitter. Yeah, because the thing here is that is because now how we are handling is edge cases here. It's all about that. Is that how we are handling is this edge cases. Exactly, an array of strings split at each point where the separator occur in the given string. right? So the idea here is that to identify when this is an empty array, okay, and when this is an array with a value here. So for example, which is again cover is these edge cases. Here, this is an element with 1, right? So as a way to now solve these specific issues, okay, if we say now, if we're receiving is this string here as part of the decode, and that string dot length is equal to 1, okay, I want you to now return is this, right? However, if the string dot length is equal to 0, we can read that property. Then I want you to return is this one. So when I run now or submit my answer for the decode, it say, hey, last execute state case, input is this, your output is this, expected output is this. Did I write right? Yeah. Input, your output was this, which means that actually we got an element. This indicates is an element, okay. For example, this actually indicate is there is an element there, okay, which means that we actually have an element there. Okay. Exactly, but if the string length is 0, so if the string length is 0, so now here we are analyzing is the edge cases. If this string length is 0, well, return this. However, if the string length is 1, okay, then return is this. So if you submit this, it says that no. This is quite interesting because it's like you are as yeah, to cover these specific edge cases here. Yes, to cover the specific edge cases here, right? Again, this is to implement instead of, okay, this is to implement our own join end string. Okay, so we're going to implement our own join end string. All right. Yep. But it's interesting because now they can handle that edge cases. which is quite interesting. Which is very, very interesting. But yeah. So the idea here of this is like, well, let's going to do this on foot. So define is a variable called result, all right? Where here we're going now to iterate through this string, which is now an array, by saying, hey, I want you to now iterate through this string of strings, which is after all an array, which means an iterable object, okay? And now here I want you to now add some sort of delimiter or separator, okay, as a way to now keep track of when I need to decode this, do this. So let's going to do this result. And also I want to know is what is the subtle difference between let and const, okay? How can we look at that? Well, by now using as a deep dive JavaScript, right? Duality. Duality. For example, here. Okay. Don't you explain that about is the let, for example? Let, no. Okay, because this is the ID. We want us to now is look at that. About the content, exactly. What JavaScript? The concept pros, the nature of JavaScript, history, new JavaScript features. Syntax. Statement versus expression, semicolon, and strict mode. Console interactive JavaScript, assertion, getting, and variables. Exactly. Okay. So this is an overview of the JavaScript syntax, booleans, big ins, and string. This is quite interesting that you can use the assert. Assert is actually part of the JavaScript. So assert in JavaScript. Console assert. Okay, that's this is part of the but this is provided by the web API, the assert, my friend. Static method write an error when the console if the assertion is false. If the assertion is true, nothing happens. Because now it's going to evaluate this assertion and the value. Any Boolean expression if the assertion is false. That's quite interesting, and that comes from the console log. All right, well, the console log API. But again, this is something that comes with the web APIs. Okay, with the web API. It's not built in on the server exactly. It's not built in on the JavaScript. This is come from this JavaScript environment. Okay. So that's why you can use this assertion. An assertion describes what the result of a computation is expected to look like and throw an exception if those expectations are incorrect. I was So this is now assertion here. Okay, this is now assertion here. That's quite interesting. Assert. Okay, an assertion describes what the result of a computation is expected to look like and throws an exception if those expectations are incorrect. So it's going to evaluate it as an expression and then it is value. An assertion, if the assertion is false, is throw an error. If the assertion is true, nothing happens. So for example, if you say is a plus 1, it's going to compute this. Okay. Reference assertion error is not defined. Okay, because after all this assert, okay, this is part of the console API, this interface. And the assert, okay, and the assert contains several methods here, right? Or not? Console assert. And the assert here, but this is from console. Reference error is not defined because this is console assert, because this is not come from the console web API. I'm going to evaluate this expression for that. Nothing happened. However, it's false. Interesting. Assert.equal. That's quite interesting because this in theory, no. Assert. Okay, but the assertion, any Boolean expression, if the assertion is false, a generic message indicates that, and the message. Okay. So for example, console assert. But the actual result and expected result is part of the Node.js assertion API, and this is explained later in the exactly. This assert is not on the web API. The assertion.equal is now on that. Okay, so if we run now a node server, god damn it. So node server online browser. Okay. With web containers. Okay. Exactly, the Node.js starter with Stack Bliss. They're using now technology called web containers that is available right now is on Google, in Chrome, but not in Firefox. No, Firefox actually enabled that. All right. Okay. All right, so now we get is the assert. This Node.js API. The assert. The assertion testing, which is now this built-in object that comes here in assert for that. Legacy assertion mode, assert deep equal. Legacy assertion mode use a double operator, which is now performing this type coercion. Okay. Okay. Assert value, assert deep equal does not match. Not deep equal, not deep strict equal. And equal. But the equal perform is this. Okay, it's legacy assertion mode. Legacy assertion mode. Assertion strict equal. Test for deep inequality between the actual and expected parameter. Deep equality means that the enumerable owns property of child objects are recursively evaluated by the following rules. Primitive values are compared using object.is, which is actually make this strict. No, it's using object.is. Okay, deep strict equal. Type tags of objects should be the same. The prototype of object are compared using the triple equal operator. Only enumerable own property are considered. Error name, message, cause, and error are always compared, even if they are not enumerable property. Errors are also compared. Enumerable own symbols. Map key and set items are compared in order. But again, this is now from Node. So in Node, we can have access to, I prefer to actually do this. It's quite a little bit more it's more boilerplate, but you can make sure what you are getting here, right? Because on the EX6, you say, hey, let me import the assert from the no internals, which is no internals assert strict. Okay, so no assert strict, and then I can now use this assert dot deep equal, which is now I can have access to this model, to this API, and perform is this deep strict equal. You can say deep strict equal. Hey, if this expression is the same for that, for example, you say, hey, is 1 plus 7 is the same for 3 plus 5. Okay, I want now to save this and run. Let's say npm run. I haven't defined a script here, so let me actually do this. So star, and then you say npm or node now index.js. all right, npm now no package manager. I want you to now run this index, and it say what in the F is this, and oh, you can say it's npm star. No, come on, man, for real. Hey, no, come on, no, man. Holy moly, what? npm star. Oh, because I need to indicate that this to the package JSON that this will be is type of Yeah, because it's using is the legacy a model resolution. Now start that, and there you got it. Exactly. If not, so for example, if this actually throw an error, it will throw an error for that. You say, hey, evaluation assertion, spec value to strictly equal for that. You know, that's exactly what it's saying. 8 is different from 12. But this assertion, part of the console, which is something that is using, for example, like yes and vtest, is one of the helpful abstraction that you can go with this. But again, since this is now working with that, and as a way to make yourself familiar with the way of how you describe that, okay, so how you mentioned about is the identifiers, okay, so this is now as an identifier, the variable's name, the statement and expression, which are completely different, okay. Statements is one line after the another, and the expressions is a piece of code to be evaluated to produce a value. So this is an expression. So to know the difference between an expression and a statement, ambiguous syntax, and what we really care about, which is now the let and const, right? So variables declared via let are mutable, okay? Variables declared via const are immutable. You must always initialize immediately. So const and immutability. In JavaScript, const only means that the binding, okay, the association between variable name and the variable, okay, they call this binding, okay, the association between the identifier or the variable's name and the variable's value is immutable. The value itself may be mutable, like object in the following example. Allowing property, exactly, allow changing property of objects here. Not allow, assigning two objects here. If the object of props is equal to 1, so it allows two property change. And const and loops, you can type error, exactly, it's a type error. You are reassigning to a new one. Exactly. Not allow assigning to object. This using is assert throw. Const and loop, you can use const with for of loop where the fresh binding is created from each iteration, because it's that each iteration, each loops, it's creating a new fresh binding here. So for example here, each iteration is creating a new fresh binding, variables names and value, and deciding between const and lets. I recommend the following rule to decide whether the const of let. Const indicates an immutable binding that a variable never changes, it is value preferred. Let indicate that the value of a variable change used only when you can use const. So indicates an immutable binding and that variable never changes, it is value. Exactly. But as long as they are, for example here, you can is redeclare, say here, say value string, okay. So for primitive value, okay, then you say string dot new value. So for primitive values, you can change, okay, but for objects, when you define this, say object, what we contain is now this number of 1, and then a string, which is a string, But for objects, it guarantees the type for that. You know, for example, you can say, hey, object, the object number, if that exists in the prototype, okay? To properly do that, and the string to it will throw This is also quite interesting. Okay, and also quite dangerous. And also quite dangerous. And also quite dangerous. And also quite dangerous. So you can do, for example, do something like this. Object will be now a number and a string, because now this is a new spacing memory. So const maintain is the immutability. God damn. At level 1. Const maintain is the immutability of level 1. Oh my god. In object at top level. En el nivel más alto. All right. Why we are looking at this? Because especially when you're defining its results, you can define its const because it will maintain its the immutability of this, which means is that you can redeclare, you can with const, okay, with const, okay, with const only means that the binding associated between the variable name and the variable is immutable. The value itself may be mutable like object. You know, variables declared via const are immutable. You must always initialize them immediately. But the const would mean, which mean, okay, so const mean is that the binding, the value, the variable, and the variable name and the value is immutable. You can change that. So for example, you say value as 1, and then you say value plus 2. You can change its type. This is also okay. It's also to enforce its immutability. This is for enforce its immutability. You can change its type to another. Oh, you shouldn't be able to actually allow you to do this. Because it's a type error, invalid assignment to const value. However, behind the scenes, it changed that. Because when you evaluate this, it doesn't guarantee you to do that. Oh shit. Because it's doing this type coercion. Oh my freaking god. Okay. But again, what this cons is guarantee you immutability at top level. So if you have an object, you can modify it. So if you have an object here with the name okay and the age 34, so by accessing to that object, and then you can and say, hey, let me now change the name. As long as it is a string, there's no problem. As long as the same type, there is no problem. However, if you change that with a different type, it actually allows you to do that. Okay? It actually allows you to do that because it's only guarantee that immutability of this value. It's guarantee you the immutability of the variable's name, the identifier, and the value, which means that it's in the same space in memory. Oh my god. Interesting. Very, very, very interesting. So, because of that, that's one of the reasons why we define here as let and cons. Okay, that's the subtle difference between the let and cons. And here is when we're going to say, okay, I want you to now take is this using the template string. I want you to get now the string, okay, and apply some delimitators. You know, you can say, hey, this will be now the delimitator or a separator. Separator. Like so. Is this one, for example. And here we add is now the separator. Alright, so anytime we want to add this string, we're going to add this. Alright, and we're going to convert this. But because at the end of the day, we want to also get is the last, whatever we got in the last result. Okay, and attach that separator. Okay, and attach that separator. So for example, like this. So initially we have an empty element, and then we have now our string, okay, and then we have is the separator. All right, because that's what we want to do initially. Okay, another interesting way to do this is by doing is this. I want you to now concatenate is this particular result with that. Which is now all of this. So by doing is this, where you now have is the So by having is this, all right, with the string and the separator, okay. Oh, as a way to count then all of this number. as a way to count all of these numbers. Okay. Which is the length. As a way to count all of these numbers. Initially, it's like, hey, and this position, okay, and this is also keep track of this. And this position you're gonna have is this. And then this. And then you're gonna return is the result. I think this is something that it might go beyond the scope of this. I can solve this, but I know what they want to do behind the scenes. They want to implement this kind of thing. So which is now doing is this. So as we now, so this is not to encode this. We safely encode all of this. So this encoding that we're going to receive here now, this is string. So we're going to have is now the position of that element, which is great. Initially, we're going to have the position of that element, all right? Followed by the separator, okay? So followed by the separator, and then the string. So with that, we get going is to actually is append that. How are we gonna do this? So because now here we're gonna define is our result, okay, as well as the index as a way to initialize, as a way to indicate, hey, we're going to iterate through this index until, you know, so iterate. We're iterating is using a while. I'm not a big fan of while, by the way, you know. We're going to iterate through this index, okay. Iterate string, okay, which is character by character. And what we are using is this. Iterate string with index 0, okay. Then we want is to do something like this. Then we want to say, all right, we're going to iterate to this string that we encode that, and now the first position will contain is now the first position will contain is the position where we're going to add that element, all right. Yeah. So what we're gonna do is to iterate through this string, all right. This is a solution. This is an own square solution, by the way.
Hey everyone. So now let's get, and once we reach, so having just a single actually show up in any words. What happens if we have a word, suppose and DE, but in the original you can see we only had 2 words, but when we get our output we're going to end up splitting this into 3 words, which is not what we wanted to do, right? We want to transform it back into what was originally given to us. So having just a single special character delimiter is not going to work, because that delimiter could actually show up in some of the words. Wouldn't it be nice if in the encoded string we somehow already knew how many characters would go in the first word, how many characters would go in the second word, etc., etc. So then we could just say, okay, let's take the first 4 characters, encode it back into the first word, then take the next 5 characters, encode it into the second word. So how could we, do something like that? Well, one way would basically be by maintaining some kind of array, right? When we're given this inputs list of strings and we want to encode it to a single string, we can, for every single word, basically have an integer, right? The first word is 4 characters, the next word is 5 characters, etc. But then where are we going to store this list? Because this is a valid solution if we're storing this list somewhere, but basically in the description, they don't want us to store any kind of state variable. This encode and decode needs to be stateless. So when we have this list 4, 5, we cannot store it in a separate data structure. Is it possible for us to store it in the string itself? How about when we're encoding this, we want to know, okay, starting at the beginning here, how many of these characters are going to be in the first word? Well, why not just put that number at the beginning, right? 4 at the beginning of this encoded string. That works because then we can look at the beginning, transform it into an integer. But one thing is, what if the word itself had some integers in it? Well, now we need another delimiter, right? We're going to have our integer always at the beginning. There's always going to be an integer at the beginning. The string is always going to start with an integer. That integer is going to represent what the length of the following word is going to be, but we're going to have a delimiter in between the integer and between the word itself. So basically, we're going to read each character until we reach the delimiter. And once we reach the delimiter, we're going to take all the characters that we just read, which are going to be transformed into an integer. So this 4 is going to be mapped to 4. And then we're going to count the next 4 characters after the delimiter, which in this case is going to be pound. And that works because we're only going to read one delimiter. We're going to expect a single pound sign no matter what, right? So even if the first character here was a pound, it still works because we're going to read an integer 4, read a single pound sign, and then say, okay, take the next 4 characters, even if they include pound, even if they included some integer like 8 or 6 or something, right? If they include integer, pound, it doesn't matter because this tells us how many characters are going to be in the first word. And then once we read those 4 characters, what are we going to expect to be next? Well, we're going to expect some word, but we want to know how long that word is going to be. So we're going to do exactly what we just did over here, having an integer followed by a pound sign, and we're going to put that same thing over here. So in this case, we're going to have a 5 and a pound sign because the next word is going to be 5 characters long. So this is kind of how we're storing the integers inside of the encoded string so that we know how to decode it. We know how long each of the strings is going to be. So I hope this makes sense. Now I'm going to show you how to actually code it up. By the way, the overall time complexity of encode and decode.
Yeah, the overall time complexity of encode and decode, it'll be the O(n) because you have to iterate through all of this. To encode is you have to iterate through all of this list of elements, and for decode you have to iterate now through all of this list, through all of these elements, all of this char in a stream.
Decode is going to be O of n, where n is going to be the total number of characters given to us in the list of words. So with that being said, we are ready to get into the code. Okay, so now let's get into the code. You can see the interface.
That makes a lot of sense, especially for encode and decode, because the entire reason of looking at this is quite simple, quite trivial. I develop now the same intuition when it comes to solve these particular problems by looking at how you're going to encode all of these elements using a delimiter, but also not only that, you need a way to actually count the numbers. Why is that? Because, for example, if that delimiter, is the same as any of this token here, for example, if our delimiter is the same as the beginning of that word, so we need to find a ways to know how, when we reach to that point, how many of these next streams or net elements actually is our words or our character. So for the result, this is exactly what we did here, and the reason why we put now is this particular pattern as a way to count this, as a way to save, write, store this information here. That's one of the reasons why a string is the way of how you can now store information here. String encode and decode. And when it comes now to decode this, so what we're gonna do here is that now that we receive that makes a lot of sense. So now that we receive that string encoded, we know what we have to do here. and that is, so find the first element in that string, followed by the limitator. If the next element is the limitator, now we know how many times we need to count to actually get that word and append to the result and append to this list. All right, and we're gonna do that. Then we're gonna identify if the next element in that string is an integer. If it is, then let me now is check if the identifier, all right, and then count the number of elements here. So as a way to do that, we can say is now the result, which will be is an array here. We can define this as const, is as let, okay, because if you define a const, the variable names and the variable values are immutable, okay. If you're working with objects, if you are now modifying is the property of that object, that won't affect that, because after all it's the same space in memory. So for example, if you say a new array here, okay, and then you try to add some elements to this. So for example, 0, the new array in this is totally valid, even though that you can say is new array dot push, say 2. So now you can is attach values to this, but you can change the type of the constant. So the TLDR is that you can change is the type of a variable name. That's what it means immutable, as a way to now prevent this funny, not funny behavior on production, which is changing the type of that. All right, okay. Okay, makes a lot of sense. So for example here, you can actually is mutate. As long as you mutate is the elements inside of this, not the referencing memory, not the type of this variable. So with that being said, I also want to use the index here. Define this index here as a const. Again, you can use mutate is the value of this, not the type, which is in this case 0. Okay, and then we're going to use now the while and say while the index is less than the string dot length. All right, because we want to now count all, we want to iterate through the entire chart collection. Okay, first I want to now is get the first element here and check get the first elements, parse that into an integer. It's like get the first element, or get the first element, parse exactly, get the first elements and parse into a get the first elements, parse into a get the first elements and parse into a number to know how many times we need to, or how many times we need to iterate to to know how many times we need to iterate in our string. Okay, to know how many times we need to iterate in our string to Yeah, to know how many times we need to iterate in our string. Yeah, get the first elements parsed into a number, and parsed into a number to know how many times we need to iterate in our string. Okay. Yeah, to know how many times we need to iterate in our string. All right. So that's why we have, yeah, to know how many times we need to iterate in our string. And the next element or separator. Yeah, and the next element, the separator, will indicate from when, exactly, will indicate where to start and stop. Okay, where to start and stop. Yep, where to start and stop. So so because here now we need to iterate here, because here we need to iterate is through all of these elements. In this case we will need to actually iterate. Okay, so we will need iterate through the substring. Okay, so by doing is this. So we will need to iterate through the substring, and by storing is a variable here called g, which must be is at the 0 position, because now this will indicate how many times we need to count, how many times we're going to iterate through that. Or we can use this as a way to store at which position we are in I. You know? So if we store at which position we are in I, and we know that from when, no, that's actually something that we're gonna keep track with I. Exactly. So here we want is to know is keep track of from where we going, from which position of the substring we're going to now count until there, right? So here we're going to now add is a while and say yeah, because while the string yeah, because after all, if we want to keep track of this, we now know okay, we now know where we are, at which position we are, and if that position that we are in the string, okay, string at the position G, okay, if the string at the position G is different, so initially it's 0. So if the position of, if the string of that position G is the limitator or separator, here I prefer to go this separator, okay, all right, if that is so if that position is separate to the, yeah, if that position, which is initially 0, is separate, is different from the separator, which means that this initially will have is our value in exact. So initially we'll have is our value. So we say, hey, if the string position is different from the separator, yes, it means that we have in that position our value. Okay, I want you to update the counter for the next one, and now in this position, okay, I want you to get the substring for that. So in this position, all right, so in this position, so once you reach to that, okay, so at that position, which is initially 0, at that position, which is initially 0, okay, this is 0 initially, right? And then you say, hey, let me now go until I don't find any. Let me now go, okay, let me now iterate this or do this. Okay, so now you're going to store is the index here, and what is the substring for that? So the length, which will be initially that position, that's right. Okay, you have now this collection. You want to iterate through all of this. Then you have now another counter which say, hey, the initial position of, I'm going to now okay, the other pointer here. Okay, so pointers. So this pointer will be now allowed me to iterate through the entire substring. But the other pointer, the other position in G, will now, or I'm going to now update that until it is different from separator. So hey, which is initially is the number. Okay, initially is the number. So I now have the position updated. Okay, exactly. So I now have the position updated from which I need to start to count them, which is in this case, it's say the parse int the string at that position that start in the I end in G, okay, base 10. All of this is just as a way to, okay, get me these elements at this position, okay, until you find it's a separator, okay, exactly, until you find is the separator, which now this will represent is the length of that, which means that for how long I need to iterate or to go through that. So this will be is the length, and then any time that I'm going to do this, I want now to update is the position in I, which will be is now G plus 1 as a way to now whether from that position in G, I want you to now start counting the other elements. I now want to start counting, which will be the initial points and the second initial pointer by updating is G with the length. by saying is G EI plus length, because now this will indicate for how long, from which position I need to actually update the pointer here. And after that, now I want is to get now that I update that, okay, because what you're doing here initially is to get the length, and then you say I'm gonna hold a pointer here on the index, which where it starts, and the G will be is the last position. I'm gonna get that, all right, and that's what I'm going to append to that, to the result, which is result dot push, and this will be string. The string of substring. So provide me that substring from the start and the end from that. So once I get that, all right, so once I update that, now I need to update my G as a way to, now I need to update my G to get now to the next position, which is the length. And after that, okay, which is the end, now my index here needs to be updated here, which is I must be G. And then when you run this again, now G will be is, and then okay, then now when you run that again, so now G and E will be in the same position. The G will increase until we find the delimitator, okay, so now you know, so now what you're gonna do is to get the length of that position, okay. G now start from when you want to count, and then you want to increase that position, which is where you really want to start, because at that position G is on the length, and then when you want to start, so now you update is the I from the index, and the G to be the length, okay. You're going to add that to the length. You're gonna get that substring and put it into the result, and so on and so forth, and holy moly, and then return, of course, the result from this. Which is the result. I mean, must be I. And then you're going to return the result. Exactly. So when you run this code, you throw your error because you say, hey, who the F is S? Which line? Oh, it's because it's a string. I mean, it's this string because after all, this is an array. Exactly. And type error. Assignment to constant variable. you want to define this, and the separator counts is a separator, like so. And this is something that is going to be generated, so and you will have to create a new fresh from scratch, and then you submit this, and then you got it. Holy moly, bro, holy moly. But this is a string and the encode here, and again this is now, oh my god. Okay, day 4, which is encode and decode, encode and decode, string encode and decode. You might wonder, why are you learning all of these things? Because this is something the solution, because this is something that allows you to now understand how you need to move around when it comes to store data. When you need to store data, when you need to when you need to store data in a string as a way to encode and decode that, how helpful it is to actually keep track of that, and also how important it is to work with this pointer things, as a way to now point and move the pointers one place to another. That's quite interesting. That's very, 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 very interesting. Holy moly. That'll be all for this video. Take care. Bye bye.